Section 8.5 root and ratio test. These are two more tests for testing for convergence or divergence in a series. They aren't really related to each other except that they both start with R, and they're both discussed in section 8.5. So let's start with the ratio test. And basically what that says, if we look at the limit as n goes to infinity for the ratio of two terms in this series, the nth term in the denominator and the nth plus 1 term in the numerator, and what the ratio test says that this is going to equal rho. Let's make this rho, and if rho is less than 1, then we get convergence. If rho, on the other hand, is greater than 1, we get divergence. And if rho is equal to 1, we don't really know what is going on. It's inconclusive. And in fact, there are some interesting cases where that may be true, and we couldn't tell what was going on. However, let's do an example really quickly. We're familiar with the geometric series, where what we're doing is we're summing a series a to the r to the nth. Okay, well, what if we apply this rule up here? Okay, so let's think about this and say, well, this would be a to the r n plus 1 divided by a to the r n. And of course we can rewrite that as a to the r to the nth times r divided by a to the r to the nth. These cancel. So rho in this case is just equal to r. So then that tells us that if r is less than 1, in other words, rho is less than 1, because in this case this is equal to rho. It looks like a P. I'm not sure. Maybe I should write rho that way, huh? Or this way. That kind of looks like a nose. I'll put a little face on that, a little smile. Yeah, there we go. Yeah, very good. Yeah, if r is less than 1, then this series converges. If r is greater than 1, then it diverges. And if r is equal to 1, then it says that this particular test is inconclusive. Okay, and that's basically how the ratio test is going to work. And once again, as is often true in this whole section about series tests, a lot of it comes down to being clever with your geometry. Okay, let's try an example to give you a feeling for how this is going to work. And I'm going to just do part A of example 1. And that gives us the series n equal to 0 to infinity of a ratio 2n plus 5, 3 to the nth. And we're trying to figure out, what does this thing do? Okay, to use the ratio test, what we would do is say, okay, let's make a ratio. And now we've got in the numerator 2n plus 1 plus 5, 3n plus 1, divided by this term here, which would be 2n plus 5, 3n. Now, this idea of making a ratio of ratios, this often comes up in the ratio test. And what we're going to do, just remember that what we're going to do is we're going to take this out of the denominator by taking its reciprocal. In other words, multiplying the reciprocal of this by both the numerator and the denominator. This will cancel this out entirely, and we multiply the top by 3n over 2n plus 5. This now goes away because we multiplied this, canceled out completely. And we see that this all cancels with all this, and we're left with just a third in the denominator. Unfortunately, we can't do any cancellation here, so let's rewrite this term as 2 raised to the n plus 1 plus 5 divided by 2n plus 5, and times 1/3, something like that. Now what are we able to do? Well, one thing we can do to adjust this is multiply through by the numerator and denominator by 1/2 to the nth. Okay? That's illegal because we're multiplying both the top and the bottom of this fraction by this number. And then this cancels here, and we get 1, 2 left, right? Because all these cancel with all these, and that leaves us 2 left. Plus, now we've got 5 divided by 2n. Okay, so far so good. We multiply this. This just becomes 1 plus 5 divided by 2n, something like that. And we can see now as n goes to infinity, right, at a limit, what's going to happen is this term isn't important at all, and this whole thing goes to 2, and we still got our 1/3 out here. So then at a limit, this thing goes to 2/3. Now, that's our rho. Let me try the new way of writing rho. Yeah, that's equal to rho. And if you come back up here by our rules, since rho is 2/3 and that's less than 1, we would say this series converges. Now, you saw basically what I did there was, I multiplied the top and the bottom by the reciprocal of the denominator to get rid of the denominator, then look for some cancelizations, and then look for some algebraic tricks with fractions, which you will love, obviously love to work with fractions, and then wind up looking for a limit, finding out what rho is, and making a conclusion. That's the basic setup for using ratio test.